The universe, with all its galaxies, stars, and mysteries, will one day come to an end. But what will that ending look like? Science has proposed several scenarios to answer one of cosmology's deepest questions. How will everything we know ultimately cease? In this series, we'll explore the most fascinating and likely cosmic endings, from the Big Freeze and the Big Rip to the Big Crunch and quantum vacuum decay. We'll discover what happens when the last star goes dark, the fate of black holes, and how time itself might change in the universe's final moments. We'll also look at modern theories, ideas of cyclic universes, and wonder, what would it be like to witness the absolute end? Join us on this journey through time and space to explore the possible endings of the universe. Let's begin with the coldest and quietest scenario of all, the Big Freeze. Picture a universe expanding endlessly, pushing galaxies farther apart and chilling space until only silence remains. This scenario, known as the Big Freeze or heat death, is one of science's most widely accepted endings for the cosmos 245. According to the second law of thermodynamics, usable energy spreads out and entropy rises. Eventually, there will no longer be enough warmth for stars to shine or energy for life or motion to exist. 1-3. Galaxies will gradually fade, stars will die, and everything will be engulfed in eternal darkness as temperatures approach absolute zero. 4. Not even black holes will endure. They too will evaporate, leaving behind a cold, empty universe. 1. Although this ending lies unimaginably far in the future, the accelerating expansion we observe today points toward this fate. 5. Yet, the Big Freeze isn't the only possible outcome. Some scenarios suggest that dark energy could play an even more dramatic role in the cosmic finale. After exploring the chilling stillness of the Big Freeze, we turn to another astonishing possibility, the Big Rip. Imagine the universe not only expanding, but accelerating, driven by a mysterious force known as dark energy. If this acceleration keeps increasing, galaxies would drift apart, and eventually even stars, planets, and atoms themselves would be torn apart. Everything from the largest structures to the tiniest particles would be pulled apart in a dramatic final act. While scientists today see the Big Rip as less likely than other endings, it highlights the immense influence of cosmic expansion and the enigmatic role of dark energy. But what if the future holds the exact opposite scenario? Next, we'll explore the Big Crunch, the universe collapsing inward. Now, let's explore one of the most dramatic scenarios for the universe's fate, the Big Crunch. Picture this. After eons of expansion, the cosmos begins to reverse course. Galaxies, stars, planets, everything starts inching closer together, as if the universe were inhaling after a vast exhale. This scenario is the opposite of the Big Freeze and the Big Rip. Here, gravity is the dominant force. If the total matter density in the universe were high enough, gravity could overcome expansion, slow it down, halt it, and eventually pull everything back together. Galaxies would no longer drift apart. Instead, they would begin an unstoppable fall toward a shared center. As the universe contracts, temperatures and energies would soar to unimaginable heights. Stars and galaxies might merge into colossal blazing masses until all matter and energy collapse into an incredibly dense, hot point, much like the conditions of the original Big Bang. It's a complete cycle, from birth to ultimate collapse. The Big Crunch leaves open a fascinating possibility that the universe doesn't end for good, but could begin anew, perhaps triggering another Big Bang. However, current evidence shows that expansion is accelerating, making the Big Crunch less likely, though not entirely ruled out. But what other threats loom for the cosmos? In the next segment, we'll dive into one of the most puzzling and mysterious possibilities, quantum vacuum decay. So far, we've explored grand scenarios where the universe freezes, rips apart, or collapses. But there is an even deeper and more mysterious possibility: the decay of quantum vacuum. To understand this, Imagine that the vacuum isn't absolute nothingness, but a restless sea filled with virtual particles that constantly flicker in and out of existence. According to modern physics, what we call vacuum is actually a state of minimal energy, but it might not be the lowest possible. There is a theoretical chance that our universe exists in what's called a false vacuum, a kind of cosmic illusion where everything seems stable, yet a deeper, more stable state could exist. If a transition happened from our current vacuum to this true vacuum, the result would be catastrophic. A bubble of true vacuum would form somewhere and expand at the speed of light, instantly rewriting the laws of physics as it swept through space. Nothing could survive this process. Atoms, stars, and even the fabric of space and time would cease to exist as we know them. The most unsettling part is that if this phenomenon is possible, it could occur at any moment, without warning. But there's no reason to panic. Calculations show that if possible at all, it is unimaginably unlikely on any human or even galactic timescale. Still, the mere possibility invites us to reflect on how fragile everything truly is. But if quantum vacuum decay never happens, what fate awaits the light and the stars? In the next segment, we'll explore how the universe could slowly fade away, star by star. So far, we've explored scenarios describing the universe's ultimate fate on the grandest scales. But there's a much quieter, slower process that marks the true dusk of all light, the death of stars. Stars, those immense engines of energy that have illuminated galaxies for billions of years, also meet their end. When a star exhausts the nuclear fuel in its core, most, including ones like our Sun, become white dwarfs. Dense, small remnants that can no longer shine as they once did. The most massive stars end their lives as neutron stars or collapse into black holes. Yet, no star is eternal. As the universe continues to expand and cool, there will come a time when no new stars are born. The old white dwarfs will gradually fade, emitting less and less light, until they become cold, dark objects known as black dwarfs. In this darkness, the last glimmers of light will come from rare collisions and the slow decay of certain radioactive elements. Cosmic night will become absolute. Galaxies once filled with stars will turn into silent graveyards of extinguished bodies. It will be the end of light and visible energy, a universe ruled by darkness and cold. In this landscape, black holes will remain, devouring matter and hiding their mysteries. But will they last forever? In our next segment, we'll see how even black holes, the giants of gravity, face their own ending. But even after the death of the stars, when the universe is plunged into darkness and silence, a few players remain: black holes. These regions of space, so dense that nothing can escape their gravity, become the final architects of the cosmos. For unimaginable ages, black holes will continue to consume whatever they encounter: lonely stars, drifting gas clouds, remnants of planets, and eventually, even smaller black holes. As the universe grows older and matter becomes scarce, black holes will dominate the cosmic landscape, merging and growing into even more massive giants. Yet, even they are not eternal. According to theory, black holes slowly emit a faint type of radiation known as Hawking radiation, causing them to gradually lose mass and energy. This process is incredibly slow. Supermassive black holes would need a time far greater than the current age of the universe to completely vanish. In the most distant future imaginable, when everything that once existed has been consumed, black holes themselves will begin to evaporate, releasing their final flashes of energy into the void. Eventually, not even they will remain, only a cold, dark, empty universe, with matter and energy almost entirely dispersed. But if time itself keeps flowing in that absolute emptiness, what does it mean to speak of an end? In the next segment, we explore the fate of time as the universe takes its final breath. As we journey through the possible endings of the universe, a profound question arises: what will happen to time at the ultimate cosmic finale? In every scenario we've explored, be it an endless freeze, a catastrophic rip, a final collapse, or a sudden quantum transformation, time is both a central player and a silent witness. In the heat-death scenario, time seems to stretch on forever. Everything slows down, stars fade away, matter disperses, and the universe expands into emptiness. The flow of time gradually loses meaning, as no energy remains to fuel change. In this state of perfect balance, time could lose its physical significance, since nothing would happen to mark its passage. In the Big Crunch, time moves toward an extreme compression. If the universe stops expanding and begins to contract, all matter and energy gather into a final point. There, time as we know it becomes distorted. At the singularity, the laws of physics break down, and our concept of time may simply dissolve. In cyclic models, time would behave like an eternal loop. After each ending, a new beginning could emerge, linking the death of one universe to the birth of another. Yet even in this scenario, time is not absolute. Every cycle reshapes what we mean by past and future. Ultimately, the fate of time is tightly linked to the fate of the universe itself. Will there come a moment when time ends? Or will it transform into something beyond human imagination? This question sits at the very heart of modern physics, setting the stage for the most widely accepted scientific theories on how the cosmos might ultimately fade away. For decades, cosmologists have debated what the true fate of the universe will be. But what does current science tell us? Until recently, the dominant theory held that the cosmos would expand indefinitely, driven by dark energy, a mysterious force that represents approximately 70% of all the mass in the universe. However, new research led by universities in Cornell, Shanghai, and international research centers is challenging this view. These studies suggest something radically different, that dark energy might not be stable, but could diminish over time. According to these more recent models, the universe would continue expanding for roughly 7 billion more years. It would reach a maximum volume 69% larger than today. Then, gravitational forces combined with a negative cosmological constant would reverse the process. The cosmos would begin to contract, accelerating progressively until it undergoes total collapse in an event known as the Big Crunch, roughly 20 billion years from now. This theory is fascinating because it suggests a cosmic cycle. The universe was born in the Big Bang 13.8 billion years ago and could end in the Big Crunch after a cycle of approximately 33 billion years. Other researchers, meanwhile, explore alternative models based on concepts like holographic dark matter, which propose completely different scenarios. The reality is that the ultimate fate of the universe remains one of science's greatest mysteries. And while cosmologists refine their models, an even more intriguing question emerges. What if the universe doesn't die permanently? After exploring scenarios where the universe could end forever, a fascinating idea emerges. What if the cosmos never faces a final ending, but instead is reborn again and again? This is the essence of cyclic universe models. According to these theories, the universe isn't a linear story with a single beginning and end, but an endless sequence of cycles: expansion, collapse, and a new beginning. The classic idea is known as the oscillating universe. Picture the cosmos expanding to a certain limit, then gravity halting this growth and pulling everything back inward, leading to a collapse called the Big Crunch. From this extreme compression, a new Big Bang would emerge, and the cycle would begin anew. Each universe is like a chapter in an infinite novel, where matter and energy are reshuffled to create a new cosmic era. In recent decades, this approach has evolved. Modern models, such as Roger Penrose's conformal cyclic cosmology, propose that even after thermal death and the dissipation of all matter, the universe could restart in unexpected ways. Here, the transition between cycles doesn't necessarily require a collapse. Instead, an extremely cold and empty universe might transform into the hot, dense start of a new cycle. While cyclic universes solve some cosmological puzzles, they also pose new challenges. like explaining how order resets and what happens to accumulated entropy. Today, science studies these models as intriguing alternatives to traditional theories, reminding us that the fate of the universe might be far more surprising than we imagine. But if the universe is reborn endlessly, what does the end truly mean? In the next segment, we'll explore what it would be like to witness the final act of existence. Imagine witnessing the universe's final moments, the instant when everything we know quietly fades away. There would be no dramatic explosions, no sudden flashes. Rather, the end would arrive as an incredibly slow, almost unnoticeable process. Space would grow colder and darker, stars would extinguish one by one, and galaxies would drift so far apart that darkness would swallow everything. In this distant scenario, matter would unravel, atoms would break apart, and even light would cease to travel. If any observers could exist so far into the future, they would watch as energy dissipates until nothing familiar remains. Black holes, after consuming what's left, would also vanish gradually, evaporating in silence. Time itself would lose all meaning. There would be no more events, no changes, no clocks marking the passing seconds. Witnessing the end of the universe would mean watching history, physics, and matter dissolve. There would be no spectators, no memories, just absolute emptiness. Everything that ever existed would become faint traces of energy scattered through a directionless, endless void. Ultimately, the universe's end would not be a spectacular event, but a serene, complete cosmic blackout. Luckily, this outcome is so unimaginably distant that, for now, we can only imagine it and be amazed by the grandeur and mystery of the cosmos. If this journey through the universe's possible endings has fascinated you, subscribe and share the series so more people can discover the wonder of the cosmos.